Today, let's understand non-parametric approaches in risk management in the simplest way possible. The big idea is this. Instead of assuming returns follow some nice clean distribution like normal or log normal, we stop guessing and just let the data speak for itself. Non-parametric methods don't force any shape on the data. They directly use historical returns, which makes them much more flexible and especially powerful when we care about extreme losses or tail risk. And in real markets, tails matter way more than theory. Now think about historical simulation. It's simple. You take past returns, sort them, and pick the percentile to get VAR. No formulas, no assumptions, very intuitive. But there's a catch. It only works at the exact data points you have. For example, if you have 100 observations, you can only calculate VAR at 99%, 98%, 97%, and so on. You can't calculate something like 95.5%, so the estimate becomes step-like and a bit rough. It's not smooth or flexible. This is where Bootstrap Historical Simulation comes in to improve things. The idea is surprisingly simple. Instead of using the same dataset once, we repeatedly resample from it with replacement. That means we randomly pick returns again and again, and the same observation can appear multiple times. Each resample creates a new fake history. For every sample, we calculate VAR. Then we repeat this hundreds or thousands of times and finally take the average of all those VARs. That average becomes our final estimate. The exact same process works for expected shortfall too. Compute ES for each resample and average them. By doing this, we reduce sampling noise and get more stable and precise risk estimates. In practice, bootstrapping usually gives better tail risk measurement than plain historical simulation. But we can go one step further. Traditional historical simulation gives us a blocky, histogram-like distribution. Imagine bars instead of a smooth curve. Because of those bars, probabilities jump suddenly, which limits accuracy. So instead, we use non-parametric density estimation. This technique smooths the histogram into a continuous curve, sometimes called a surrogate density function. The shape still follows the real data, but now it's smooth. And once the curve is smooth, we can calculate VAR at any confidence level. 95%, 95.5%, 99.3%, anything we want. That makes the model far more flexible and realistic. So to summarize the intuition, historical simulation uses raw past data with no assumptions. Bootstrapping improves stability by repeatedly resampling and averaging risk estimates, and non-parametric density smoothing turns the step-like distribution into a continuous one, so we can compute risk more accurately, especially in the tails. The core philosophy behind all these methods is simple. Don't assume the world is normal. Trust the data you actually observe.